Hi, I didn't see you there. My name is Steven, and welcome to Chemistry 101, where today we'll be discussing Guy Lussac's law of gas, with your friends in mind.
Ryan?
And boy,
Ah, splendid. Thanks, Ryan and Bowie. And now, viewer, you may be wondering, how are you going to show off Guy Lussac's law? And to that I must say, we will be using an ordinary glass bottle and a candlestick, accompanied by the legendary egg, in order to show that the egg can be sucked into a bottle that is clearly smaller than an egg should be able to fit into. Now, let's go to Bowie with the explanation.
by applying Lusac's law to our experiment, P1 over T1 equals P2 over T2, it is demonstrated that when adding heat to a container, pressure will begin to exert out of the container, and resulting in the external pressure equalizing to the internal pressure, also known as high pressure moving to low pressure, pushing the hard-boiled egg inside of the container.
Alright, Bowie. Now, on to the demonstration with Ryan. Alright, thanks Ryan for the demonstration of this experiment, and thank you again Bowie for the explanation of the equation itself. Now, on to why this experiment works in the first place. Let's get right into it. Alright, so, as discussed before, external pressure in this instance is constant and will not change no matter what you do to this experiment. However, there are two variables that will change depending on how you execute this experiment. And those two variables are the number of moles and the temperature, as you can see from the candle and ultimately what I am about to show you. So, initially, the internal and external pressures present are equal. This is represented by the 6 dots on the outside representing the external pressure, and the 6 dots within the beaker itself representing the internal pressure. These two pressures are always equal because pressure will always find a way to stabilize and equalize. Now, as you introduce the egg and candle as a new component to this experiment, however, the egg is creating a vacuum seal, and as discussed before, nothing can enter or escape. So the moles that are in here presently are in here and they cannot escape. But with the flame, fire takes up oxygen and needs oxygen to burn. And as you saw in the demonstration, the fire eventually burns out. And that is because the fire is taking up all the oxygen molecules inside of the beaker itself. So, in fact, there is not an increase of pressure, but rather a decrease of pressure because of the oxygen that is being taken away by the flame. And as the flame eats up all the oxygen, there is less moles of oxygen left inside of the beaker itself, and as the flame goes out, there is less pressure inside of the beaker. And now, since the external pressure is now higher, it must go into the beaker to fill in and equalize. And that is why the egg plops inside of the beaker when this experiment is performed.
Thus, our experiment demonstrates Guy Lussac's law because the temperature and pressure inside the beaker decreases as a result of placing the egg on top of the beaker. This means that pressure and temperature are directly proportional.